Hi, this is Mr. Nazarian. Our lesson objective today is I can understand and explain the value of digits in a larger number. It's 5th grade standard, numbers base 10A1. So if you were to guess what the number one mathematical mistake that students make from kindergarten through 12th grade is, what do you think that would be? Drum roll, please. It is place value. And while mistakes are fine, we all make mistakes, it's part of being human, we want to learn from our mistakes and we want to minimize them. So we're going to review place values today, take a look at that, and when we really have it down pat, then we'll be ready to move on to new things in 5th grade. So one really important thing to think about when we're thinking about numbers and math is that we use a base 10 number system. So what does that mean? Well, for starters, it means that in our number system that we have 10 digits exactly. While the amount of different numbers that there are is infinite, every number is made up of these digits, and there's no other digits other than these 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All numbers are comprised of some combination of these digits. So the other thing about a base 10 system is that in each place value, there can only be one digit. There can only exist one digit in each place value. So for example, the number 9 is how many digits? It's one digit, right? There we go. But the number 10 is how many digits? It's one number, but how many digits is it? It is 2 digits, right? It is comprised of a 1 and a 0. What makes a 10 different from, say, this number? Has the same digits, right? 1 and a 0, 1 and a 0. But what makes them different is their placement. This is in the 1's place, and this is in the 0's place. So this number, even though it has the same digits, because where the digits are, the location of those digits, makes it a completely different value. This is worth 10, this is worth 1. What would you rather have, $1 or $10? So we're going to look at that actually by looking at money. So if I gave you $3, that would look like this, right? But if I gave you, let's say I gave you $33, now I could get 30 more of these singles, right, of these $1 bills, and stuff them all in here. The thing is that they won't fit. I can't do that. I can't fit any more than 9 in here, because remember that only a single digit can fit in each place value. The largest single digit that there is 9. So I could fit 9 all the way up to 9 in here. I could fit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but I can't fit any more than 9 singles in here, right? Because there only can be one digit. So this won't work, this 33. So what I have to do is I look at this place value, and I know that because place values go like this, right? Ones, tens, hundreds, thousands. This is right here the ones place. So I can keep my 3 $1 bills here. But this is in the tens place, which means I'm going to need 3 $10 bills. So 3 tens is equal to what? 3 times 10 would be 30. And then 3 ones, 3 times 1 is 3, right? So now we have our 33. So that works. Now let's say that I gave you $333 just because you're that great of a student. I wanted to have a hole burn in my pocket. I wanted to give you $333. Now, again, this is way more than one digit, right? So I only can have this one digit here, this is the ones place, right? So I have my 1, 2, 3 here. Then the next place value over is the tens place, so I have my 3 tens, 1, 2, 3. This next place value is the hundreds place, correct? So that means I'm going to need how many hundreds? I'm going to need 3 hundreds. So now we've got 3 times 100 gives us 300. That's what we got here. 3 tens is 30, and 3 ones is 3. So now you have 333. The last thing that really quick want to think about and look at is, what do you notice about as we move from the place values from right to left? So each one of these, there's 3 bills, right? I got my 3 $1 bills, my 3 $10 bills, my 3 $100 bills. What pattern do you notice is occurring when we move from the right to the left? So every time we move from this place value from the right over to the left one, and then when we move from the right here to the left another one here, what is happening to the value of each of those bills? So in this bill it's worth 1, right? But then that same just one of them here is worth 10, right? Or 3, and then it turns to 30, even though it's the same amount of bills. So what's happening to that value? It is increasing by what amount? So in other words, times what? 3 times 10 is 30, right? Or 1 times 10 is 10. So when you move from the right to the left, from the ones to the tens place, the value of the digit increases by 10. And what do you see when we move from the tens to the hundreds? So when we have 1 10 or 1 100, how many times greater is 100 than 10? Or you could think of it as how many tens would I need to fill up to be worth 100? If you said it is also 10 times greater, then you're correct. And as we move to larger and larger and larger numbers, we will notice this pattern continues. Every time that we move from the right to the left, the value of the digit increases by 10. All right, we will work more on place value tomorrow. See you then.